be talking with MineTeck is going to be talking about their solution. Are you going to be doing e-waste, Gilbert?
We're going to touch on it just briefly and hope that you invite us back after this one.
All right, so MineTeck's solution is that they're able to pull metals out of the tailings from mining or other environmental soils. Is that correct, Gilbert?
Yes.
Okay. So then I think this has a lot of applications. I know I had people from DTRA that replied, so I hope somebody from DTRA shows up here. If not, I'll make sure that they get the video, because I know they have some things that they're working on with soil cleanup and stuff like that. So if there are no questions now, I will turn it over to Gilbert. So go ahead, Gilbert.
All right. Can you hear me okay?
Yeah.
Okay, beautiful. Yeah, thank you for having us, Eugene. It's been a long time coming. And Brian, thank you for the introduction to Eugene many moons ago, and looking forward to catching up with you after the call. Yeah, I'm here with my longtime friend and partner, Andrew Ferguson, CEO of MineTeck. I'm Gilbert Jones, by the way. We're in Evergreen, Colorado, and working on our third year of production this year. And so it's a pretty big year for us, and we can get into the technology. Pretty excited to be here. Let's see if we can flip this. Okay, there we go. So yeah, MineTeck provides technologies for reclamation of precious and critical metals from legacy mine sites, as Eugene said, dump ore and tailings piles. I'll delineate between the two here shortly. We specialize in non-toxic mineral processing designed specifically for sites that are environmentally sensitive, historically abandoned, or otherwise constrained by modern permitting standards. Permitting is a huge issue, and that's kind of the feather in the cap that MineTeck offers. Whoops, going the other way.
Whoops.
There we go. Many of you may know this already. Mobile phones, we all use them. I think at least one person on this call has a mobile phone, and it requires about 40 different elements just to produce that phone. And in the process, you have this aftermath of 7.5 tons, 14,000 pounds of tailings in the process. Gold production per second produces about 5 cubic meters of tailings and about 3 cubic meters for copper. We actually worked with Colorado School of Mines about 5 years ago and talked with one of their tailings storage heads. She was the dean at that time, or just coming out of her deanship, if you will. And she helped us with many of the research that had gone into this part of this presentation. But the societal demands at that time were about 20 billion tons of minerals each year globally. And with data centers and AI pushes, robotics, and many other things, we're seeing those demands increase closer to 100 billion tons each year, and probably closer to that value real time. And so we as MineTeck realize that there's a new vision of the industry that's required to redefine the process and just address these problems differently, looking at the waste to value streams and being more proactive about the approaches. And even with Brian and some of the applications we talked about, Eugene, just having more closed loop systems to basically use all of the material that's there. And you'll see that in the next slide. This picture really says many different things, and I'll break that down layer by layer. This is a gemstone or a gem mine from over 100 years ago, where they took dump ore. So dump ore hasn't been actually processed. They used this method called ore dressing at the time, which they just aesthetically looked at the potential metal content, precious metals. They were targeting gold. And at that time, the prices were probably somewhere around $20 an ounce. And so they threw this material off to the side of the hill, and with the mining bans that occurred prior to the First World War, nobody actually went back to this site. And for the several decades following the First World War, you would need a permit to actually reclaim this material. And so another issue that happens is once this material has actually been mined, you take about 2% of the metals out of this, and you're still left with this massive pile. So you could take all the precious metals out that you want, and you could probably reshape this pile pretty close to it. And so it's more how the waste is being accumulated and some of the other issues associated with this. State of Colorado has 28,000 abandoned sites like this. There's 18,000 mines that are actually that are inoperable, and so you have plenty of sites just like this. It's got acidic properties. That's why you're not seeing any vegetation growing directly on it. And you mix that in with the rainwater and precipitation from snow and other elements, and this is a perfect situation for acidic mine drainage. The access roads here are very tight and limited, and one of our applications addresses that, which we'll get into here in a minute. But so yeah, we as MineTeck create custom systems depending on what the application is, and the biggest thing is just getting a permit. So on this last slide, Andrew and I actually standing at this 80-year-old customer site about 5 years ago. Actually, I think I was just getting married at that time. Andrew and I were standing on this pile, and gentleman couldn't get a permit to save himself. So he's, number one, got depreciated land assets and can't do anything to actually reclaim this pile. So we're able to, with our technology, obtain those permits. And our co-founder actually, who got the first toll mill permitted, which we'll address here in a minute, he got a permit right on Clear Creek, which flows right into Coors Brewery. And they basically said, there's no way you're going to get a permit. This is right off the I-70, for those of you who might be familiar with Colorado. And that's a major highway going from Denver to the foothills and then into ski country. So it's really a sensitive area from that regard. And to have a process that's permittable is really a huge milestone.
So,
and so yeah, go ahead.
This is Eugene. So now when you're talking about this application and the permit, was it your technology that made it or helped to make it permittable?
Yes, we actually had to, and we had a third party, or Jay had a third party lab up in Canada do a test to show that there was, zero toxic properties associated with the tailings after being processed for 1,000 years. And so when the Department of Reclamation and Mining Safety and the EPA were kind of brought up to speed on this test, they had never heard of it, number one, but he had to come up with specific handling procedures just to get that permit. And then after many years of just cultivating the relationship, understanding the data, they realized that because this is a closed loop circuit, there is no discharge, and you're able to stabilize waste if there are any. Each pile is different. We're not using any harmful chemicals. They were able to warrant that or issue that permit.
And so back to now to actually to zero toxicity. Are you pulling existing toxins out, or just not adding new toxins, or both?
So it's both. We're able, where there are toxic properties, isolate and then control those. And we're not using heavy chemicals like cyanide and mercury and other very harmful acidic reagents. So it's both. Yeah.
So then there are more applications beyond precious metals for this. I mean, you can potentially detoxify, if that's a word, a property.
Yeah.
Yeah.
Again. Yeah. Go ahead, Andy.
Well, I'll jump in. Jay, our partner and founder, inventor of this solution, actually was brought in on the Palestine train derailment situation, and this solution was actually
that was in Ohio, right?
Yeah, in Palestine, Ohio, to clean the water and some of the soils there. We were not in control of that, but he was brought in as an advisor, and some of the technology was used in that. So MineTeck on our own has only applied this to, historic mining materials and toll milling thus far. So, but we've also, Jay has also been instrumental in treating a issue with Legionnaire's disease in water, and purifying the water and getting the disease out of the water. And that was for the boat, the tour boats. I can't think of the name that we use. Anyway, the big boats that go take people around. They were having problems with their water systems, and so he was brought in on that. So there's a lot of applications that we believe this can be applied to, but we haven't necessarily done a broad base of them beyond our target right now.
Whoops.
Okay, so
Whoops.
I guess then you're talking about, you're referring to cruise ships.
Yes, thank you. I couldn't think of the name for some reason. Call it a senior moment.
So then there could be applications for
Whoops.
I don't know if it would work for desalinization for Navy ships, or to help clean up their water, I guess, as well. Okay.
Mm-hmm.
So there are applications there.
Yeah.
Whoops.
All right, go ahead.
Whoops.
Bill, back to you.
Yeah. So, and we would stabilize those materials. There's different applications for repurposing that, so you can actually stabilize it, control it. That plasma technology you'd mentioned ahead of the call might be helpful in maybe just high heating or neutralizing things further. But you can repurpose this as a building product. If you're only, let's say, targeting precious metals, there's still other nutrient dense elements in these piles that, when mixed with other organics, actually make a wonderful fertilizer. So that's another application as well. You can have, obviously, road base reclamation type materials. So we can support mining in that regard, and some of these other building products, depending on what the applications look like.
All right,
quick question.
Any questions?
We got a question from Don. Yeah, go ahead, Don.
Yeah, quick question. Thank you. Hey, the soil decontamination element really piqued my interest. Do you have if we had hot soil that was, low level radioactive, that was dirty, could you guys do a mitigation plan and process either soil where a petroleum, oil spill? You mentioned the train incident in Ohio, where either a petroleum incident had occurred or radioactive stuff was stored on the ground or on top of the ground, and it leached into the existing topsoil?
Theoretically, yes. We would have to, examine the soil and do some testing, before we could make any commitment or claims. But yes, theoretically.
Yeah, and as my mind is racing, there's a plethora of EPA Superfund sites.
Yeah.
And typically that's the tallest pole in the tent, as people not having the ability to mitigate, soil remediation. So
right,
that may be an excellent. If you ever run out of work, it might be an excellent source to look for your next challenge.
Yeah, and I mean that's a great point, Don. Where we are in Colorado is actually a Superfund site. The challenge that we're having is that the EPA designated that site like 20 years ago, and have spent, millions and millions of dollars trying to address the problem without really fixing the problem, but only, like halfway stopping it from getting worse. And so currently, because of the age of the designation and all that kind of stuff, like there's no funds directly through the EPA for us to get. I mean, we've knocked on that door now for several years, and we're basically told that, this thing is an old problem and nobody's wanting to throw money at it. So we are aware of Superfund sites, but with budgeting and different issues, getting, funds from the government is not the easiest or straightforward thing. So if there's anybody that has a secret on accessing that, we would definitely be interested in helping, because we're, like I say, we're operating within a Superfund site, but without any benefit of that designation.
Just speaking to that a little bit, I will say that given the, the nature of those Superfund sites, they're often used as research subjects, essentially, to prototype something. You might look into collaborating with maybe one of the national labs or something similar to that. Meet up with those folks at the Superfund site and just use as a test case, prove your technology works, and in the process, kind of get your foot in the door. And that might be the right path. Find some grant funded initial proof of principle, and then from there, I think the doors will open for you.
Great, thank you.
Do you have any
Appreciate
connections there?
So I'm over at LANL, the Los Alamos National Laboratory. So we're just
Right.
hop, skip, and jump down south of you. I would say, I mean, I'm happy to be reached out to, and I can try and find a good person for you. I'm probably not the right person for you. That said, I would just keep an eye out for the grants that are called around this sort of thing. They're coming out right now and consistently. And of course, anything you can link to critical minerals right now, that's all the rage nowadays in the funding sphere. I would say find a grant and then find your collaborator you want to work with, or just go directly to the Superfund site. They probably have a DOE office there, and they might just be willing to be the PIs or the PIs or co-PIs to give you access, and they might be really intrigued by your ideas. So I think that's probably the best place. Just knock on a door down there, make the call, and once you have a grant in mind, say, hey, let's see if this technology works using your waste products, and let's see if we make this work.
Awesome.
Yeah, and I can connect you to Energy Works. I don't know how broad they work across the DOE, but we also work with PNNL and Sandia through the Tech ID ecosystem. Mr. Best.
Hey, good afternoon. Hey, one quick question. So once your solution gets dirty, i.e. from cleaning, let's just say the last person raised low-level radioactive waste, would it essentially have to stay in place to process another low-level waste stream, i.e. because you couldn't technically clean it up enough to, move it to a environmental site where you're worried about, I don't know, element A in the water? Does that make sense?
If I understand your question, is how do we ultimately get rid of the toxic element?
Out of your equipment, out of the process that processed the waste.
Yeah,
that makes sense.
So again, without having expertise on the radioactive side of things, speaking to other things, the system can be cleaned, rinsed. The water is captured or in a closed loop system, and so it's essentially trapped and can be removed in an appropriate manner depending on what the material is, and then disposed of at a approved toxic disposal site or burned, depending on what it is.
Thank you.
Yeah, the comments in the chat were about avoiding cross-contamination. And I think you might be able to see that when we get to the makeup of the solution. So, are there any more questions?
Good questions. Yeah.
All right. Gilbert, do you want to move on?
Sure. Yeah, just more about where it applies. And
Right.
I think that was Don that it said the Superfund sites. But yeah, the
Right.
brownfield EPA designated hazardous sites, that would be an application. But primarily we've been using it in legacy mine reclamation in the dump or tailings scenarios. Eugene, when we had talked earlier on, like the Colorado River incident, there's 3 million tons of basically wastewater that spilled into, a number of different water sources, but definitely the Colorado River. And then the question around, can we do oil cleanups? That application would need to be tested further, but it's something that we believe that we could support with, like the Chesapeake Bay situation. So yeah, both applications would be relevant, as we discussed. Precious and critical mineral. That's been our primary focus in Colorado, with all the abandoned mines and just the obtaining the permit there. We're very familiar with how things are handled in the state of Colorado and engaging with the local stakeholders between the DRMS and EPA locally there. And yes, it would be a preventative measure for acidic mine drainage.
Okay.
Any
If I
other
can,
questions on this slide, or?
Does not appear so.
Good.
Okay. Yeah, and it's shown on that first image, primarily working with private landowners at the moment. It's an 80-year-old gentleman that is looking to, actually, it's his lifelong dream to get rid of this pile that's sitting on his property and potentially mine it. He was a geologist of sorts previously and could never just get a permit or come up with the resources to handle the pile. And that's largely what we're running into in the state of Colorado specifically. The 4 largest landowners have basically reached out in one shape or fashion to say, hey, we could really use your support in getting a permit and being educated on the process to actually recover the precious metals and reclaim the land. As I said, the DRMS, EPA were part of the main points of contact in the state of Colorado to get permits. In some cases, we would engage with the BLM. But yeah, mining operators, there's easily a handful of operators in close proximity to where our home office is in Evergreen, and we've been working with them in preliminary conversations. You had mentioned the laboratory. I think that was it James? Maybe that was Mr. Singer. But yeah, we would want to collaborate with laboratories and get this technology out further. We had been in conversations with Colorado School of Mines to understand just the tailings storage dynamic. Land is a very precious resource, and if you can be proactive to prevent sort of these tailings spills and eliminate the need for tailings ponds, it's a big need right now. And Eugene, you'd asked if we would bring up the e-waste application. That's another area we could use a similar technology in. When we talk about printed computer boards at end of life and some of the electronics that are being recycled. We just did a pilot project in the state of Washington, and we were able to safely recover precious metals from that application. So if you're kind enough to invite us back, we'd like to do a separate presentation on that.
No, that'd be good. I'd probably have you come back when the plasma incinerator people present, because that would be a great tie-in, because I think there's a really good collaboration opportunity for the two of you there to combine your solutions.
Beautiful.
Because you could go into any trash dump, and they can incinerate everything with plasma, and then you can go through the ash and recover all the toxic and metals and then turn the ash into brick.
Yeah, I just heard there's like 48% of electronics actually get recycled in the United States. So there's definitely a lot left on the table.
Yeah.
The debate.
So yeah, we would love to come back and collaborate there.
Sounds good.
The debate. The debate. The debate.
Yeah, Andy, you want to touch on the MRU? This is kind of the flagship of all of our testing. And
Do you want to
it'd be
show the
great for
picture
those.
first? Can we look at the picture and then
Yeah, we
come
moved
back to
it.
this?
Yeah,
There we go.
this is
Okay,
it.
yeah.
Yeah. So, this is a picture of our filtration system for one of the units. You see a series of 55-gallon drums. They have filters in them that are proprietary, and along with our chemistry that is adjusted per the material that we're filtering, and the size and configuration of the filtration part of the system is based on the volume of the material that we're trying to process, and the nature of that material. So this one piece kind of has to be dynamically reconfigured or redesigned for any unique material. So Gil, if you can go back to the other slide.
Sure.
Our partner and the founder of the technology actually created the technology over a period of more than a decade in the concrete industry, because an expert at all the different types of concrete needed, the different set times, temperature reactions. He's an expert at like leveling buildings by using concrete to push the buildings up and so on and so forth. I don't want to begin to even explain his level of expertise, but it was in that material management where he was evaluating materials at a granular level, and realized, partly because he's also from a historically mining family, he came up with some ideas around how this could be applied for mining. And so he actually approached the toll mill first, and so the permit was granted first, and we're going to get to that in a second, because that's really what we consider to be our keystone property and what we have available. But given the issue with all the properties that you'll identified, 28,000 abandoned mines in Colorado. There are thousands and thousands of the piles all around, and trucking is not economically viable. Some of these piles are smaller, some larger, and so having a mobile solution has kind of been the holy grail for the industry. Lots of people have had the ideas, but nobody's really pulled it off, especially one that can deal with environmental issues. I mean, there's a lot of guys working on, basically mobile mining systems, but to one that can actually recover and do a clean job and not leave toxins, that hasn't been done. And so we spent a good portion of the last 3 years building what we call our mobile research unit.
Andrew,
and,
can I interrupt you for a second?
Yeah.
Can you turn off your video, because your audio is breaking up?
Okay, sure.
And maybe save some bandwidth. All right, thank you.
Yeah. So the system is obviously mobile, and depending on the size, the number of trailers that would be involved would be different. It's self-contained. It involves a closed loop system where the water is recirculated, treated, reused. There's zero liquid discharge on the property, which is a big impact or lack of impact on the environment. And we capture the toxins in the process of filtering the water. And so, we change out the filter tank, so to speak, every at some regular interval, again, depending on the volume, so that, we have clean enough water being used in the system. And what happens, in the end is, as Gilbert has been referring to, the byproduct, which is really the bulk of the product, because when you're mining, if you have a 1 to 2% target of precious metals, I mean, you're looking at a really rich pile. And so you have 99% of the material processing has to go somewhere else. And that's, what creates the tailings piles typically, because you've mined it, you've processed it, but in the traditional mining space, you haven't taken out, the arsenic, you haven't taken out lead, you haven't taken out any identifiable toxins. And so that material becomes a liability, and you have to create a tailings pond and a tailings management program as a legacy to any mining activity. And this is what has, completely stopped the industry. Unless you're a, major player like Newmont or Barrick, you don't have the resources, to pay the dues, to get the permits and so on and so forth. But with our MRU, we actually last year were issued the first reclamation permit of its kind, to do a reclamation of a site in central Colorado near Central City, to clean up a pretty sizable waste pile, somewhere 35,000 tons of material sitting on the ground. And so we are in the process of doing that. We have our MRU on site, and it is a demonstration of our permitting capability and of our processing capability. We were only able to get the permit because of the technology and the system, and to warrant that we weren't going to contaminate the land. We had to test the byproduct to show that it was not toxic, and so that it's actually can be resold as road fill or septic tank fill. And that was a pretty big achievement. And that's really what's needed to make this work, is to create this, what we call circular economy, where you're not just processing for precious metal values, you're actually creating a product out of the largest volume of the material that you're producing, and being able to sell that and get it off the property. So we have our flagship unit built. It's a pilot. It's a demonstration unit. It will need to be tweaked. But this is the flagship of our future equipment sales, where we envision, dozens, if not hundreds of these systems being deployed, all around the world, particularly in environmentally sensitive locations, or in farther out of the way places, and, maybe the smaller piles that won't warrant a large investment of, a fixed infrastructure. And Gil, I think if you go to the next slide, or the one after the picture, there's addressed other things. So the modular trailer system is able to characterize material chemistry on site. And so it's used as a validation. It can be used to validate recovery and environmental outcomes. So let's say that there is a large tailings pile somewhere, or a mined waste pile somewhere, and ultimately the best plan would be to build something more permanent. Well, you can use our system to validate the assumptions that are used to warrant the build out while you're getting the permit, because the permit to get a permanent facility approved is going to take a lot longer than the permit to get our mobile site. So our mobile site, our permit, our reclamation permit, was approved in 6 months. And typically for a major construction site of a tailings pond, or some activity like that, you're looking at 18 months plus. So this reduces risk. It can reduce capital before scaling to know that you're going to get good results out of it. And or it can just do the job. It might take longer, but it can do the job, get your property cleaned up and get the property back into, its best use, which is huge. The fact that you're not building a permanent site means you're not making permanent modifications to the property that are going to be residual or legacy to that property or have to, be removed, in the final reclamation. So these are all the benefits to a modular system that we are pioneering right now. We're actually shut down for the winter because we weren't able to winterize the location, prior to this last winter setting up. So we hope to be back in operations, end of April or May when the weather breaks. So questions, or back to you, Gil.
What's the volume?
Yeah, so we've learned that 15 tons an hour is probably maximum for a closed loop system to be able to properly manage the water. You get more volume than that, you're going to have problems, really, keeping the water, on site. And, if there's leaks, you don't want to, have a major problem. So this is one of the things that we learned. We were actually originally targeting to see if we could get to 30, but we've learned through our first implementation that 15 is probably max, and we can build anything smaller than that. And so we're thinking 2 tons an hour, 5 tons an hour, 10 tons an hour. It might be different size units.
Multiple units.
Yeah.
This is Eugene again. Oh, go ahead, Nick.
I was going to say, have you extracted lithium?
We have not. Everything we've done thus far, other than the specialty applications I mentioned earlier in terms of being brought into the Palestine, Ohio oil spill and the Legionnaire's disease situation that our partner was brought into, our primary application has been, the Colorado legacy mine tailings and waste.
The reason I ask is that my cousin in Cornwall, UK, where they mined tin for decades and centuries. And I would definitely want to introduce this to them because they're reopening some of the mines now, and, for cleaning up some of the existing tailings, etc.
Yeah. Okay, that'd be excellent. Yeah. Okay, Gil, back to you.
I was going to ask, how long are you on site? Or is that just going to depend on the volume?
Depends on the size of the pile and the volume that we're running. For the site that we're currently working, we expect to be there 2 years.
Okay. Thank you.
And you're welcome to people coming and visiting the site and scheduling a tour.
Sure.
Andy, do you want to touch base on the Gladstone as well?
Sure.
So before we move on here, so Jeremy, we had a question earlier about DOE. So I know you missed the beginning of the meeting. I'm gonna send it to you and see if you can help us out.
I'll try.
Okay. Because there were some DOE applications that we talked about with somebody from Lannel, and I know you're at PNNL, so. All right, sorry about that, Gilbert.
No problem.
Yeah. So,
No worries.
like I said, the the mobile unit was something that we shifted on because we were being asked by so many property owners, as well as the DRMS and county officials, in terms of what we could do to help facilitate property cleanup. But prior to that, our founder actually, as Gil mentioned earlier in the call, was actually able to get a permit for the first permitted toll mill in Colorado in over 20 years, and is currently the only permitted toll mill in Colorado. We are in between. We are not up and running at the moment. The picture that you see is a picture of the pilot mill. That was a 3-ton per hour mill that was used to validate the technology proof of concept. And it's on a 12-acre property, in central Colorado, right off of I-70, right adjacent. I mean, literally, hundreds of feet from Clear Creek itself, which is a major waterway flowing into directly down into Golden, Colorado, where Coors Brewery is. And so it's a very protected water source. But we have not only the only permitted toll mill in Colorado right now, we have it right on this piece of property that is adjoins the Clear Creek waterway. So the land value is about $600,000. We spent over $300,000 in permitting it. We've got $400,000 in infrastructure in terms of concrete and power and things. We have $800,000 of the equipment that is going to be needed to upgrade to a 30-ton per hour facility, and over $1 million in the R&D and engineering that went into it. As a toll mill, doing for others, we are estimating that we can do at least $17 million a year just as a toll mill. However, it's probably more profitable for us to have our own material to process, because we can do, depending on the grade of the material, up to $40 million a year in terms of revenue. So this really is our keystone project for MineTeck. We were, delayed in getting the transition mapped out and so on. So we're currently seeking funding to build out the commercial scale of this mill and, get it up to 30 tons per hour, and be able to open up our doors for service sometime next year, because it'll take us about a year to fully get it upgraded and tested and so on and so forth. But that's where the technology was validated. It's a regulatory precedent for future MineTeck deployments, meaning that the fact that we have 2 permits, the only 2 permits of their kind issued in Colorado in over 20 years, is really the proof of concept for our technology, that the DRMS has basically endorsed what we're doing and wants to see the technology expanded. And so it's critical that we increase this pilot plant to a full commercial capacity of 30 tons an hour.
So now, this is Eugene again. So Nick had brought up about someone that he knows in the UK.
Mm-hmm.
Would you be able to support operations in the UK or in Africa or other places outside of North America?
Yeah, potentially. And I say that only because we're still a very small company. But if resources are brought in as part of the picture, I mean, we would start with laboratory testing and evaluation of any material or liquids that were involved in whatever project. So if somebody in England, like Nick mentioned, wants to send us some of the material, we have a service that we provide for material evaluation. And that's where we would start with any project, is having the material evaluated for our process and in our laboratory. And that would be combined with outside testing, assays and laboratories that we use to confirm our own results. And that gives us a basis of characterizing the material to know, whether the application would be appropriate and what changes or tweaks to the process would need to be implemented, because, for instance, the flocculants that we might use for lithium might be different than what we're using for sulfides and, gold recovery.
Right. And then how much of a sample do you need? I mean, is it like, I guess by volume?
Yeah, to start with, it's typically like 5 gallons.
Okay. And then I don't know if I'm crossing into your IP, but just knowing people that are part of the ecosystem in your cleaning process, is it chemical and biological, or is it just chemical, or do you not want to share that?
Well,
a conversation we should have offline.
Yeah, we should have that offline.
Okay.
I would say it's both. Yeah.
Okay, because I know people that are doing work in the microbiome that may be able to identify microbes that could benefit you.
Yeah. We understand that there's a lot of work on this area across a broad spectrum of industries. And this is where your community forum is a great thing, because, there can be cross-pollination of this knowledge, to improve all of our processes.
Right.
This is Brian Crowley. I have a comment and a question.
Mm-hmm.
I've gold mined. I've had claims worth tens of millions, if not hundreds of millions of dollars in my name.
Mm-hmm.
I've seen people lose hundreds of millions, if not billions of dollars in Nevada, Idaho, and Oregon. And in almost every single situation, almost every single time, the number one reason that causes everyone a problem is what to do with the mine tailings and the wastewater that comes off the property.
Yep.
When you say it's the number one problem, I just really want to stress just how remarkable it can be if you can literally open up the North American mining sectors
right
within a short time span, simply because you no longer produce toxic sludge and wastewater off the mine site. Because it is the only thing that the EPA has the power to do is shut you down because of the discharge permit.
Yep. Absolutely right, Brian. You nailed it.
You mentioned something about the 98% waste. Can some of that be put into a concrete mix?
Absolutely. Yeah, that's what we're saying, is that 98% byproduct, or Priscilla from the School of Mines that Gilbert mentioned before, she's always quick to say that's actually the product. You're actually producing, tailings, and you've got a little side business collecting your precious metals just based on volume. And what Brian just said, is true, and what you're saying, Nick, is true, that the tailings are the issue, and not being able to manage the tailings is what has shut down mining in North America. And it is our dream to basically reclaim the mining industry. We talk about reclaiming properties, but we're really after is reclaiming the industry. And we're a very small company. We're dreamers. We're visionaries. But we've been able to do what nobody else has been able to do in over 20 years in Colorado, and that's get 2 different permits that really stand in the face of this issue. One for a toll mill and one for a reclamation site. So, we're not where we want to be yet in terms of 100 people working at multiple sites and, just chug it along. But that's where, that's why we're on this forum and seeking help. We need money, and we need, more help and connections. But, people like Brian and people that Brian knows, and maybe everybody else on the call that knows these miners that have lost bucks trying to get something done, but just can't get past that issue. That's the issue. That is the issue.
I would also like to add, I love the idea that you're making things modular. So when you go into the BLM office and you say you want to mine a property, they're going to say your bond and insurance is low because the equipment is easy to remove and clean up.
Yep.
And then almost in every situation, I guarantee you, they're going to want to come out and see this marvelous invention that you have brought to their forest. Because throughout all of the history, all the Forest Service has ever tried to do is fight the miner and shut them down at every point they possibly could.
Yeah.
I think they're going to love this.
Oh, the simplicity of it is amazing. It doesn't have to be, solutions don't have to be complicated.
Right.
I wanted to address, Barry Blackman came in late. Mr. Blackman, are you able to unmute?
Yes, thank you very much. Sorry, my schedule didn't allow me to be in early enough. I'm coming into the conversation late and where we want to go.
Okay, was there anything that you wanted to see at this point?
Well, obviously, I'm going to go back and listen to the whole recording, after this meeting and everything else. I don't want to hold everybody up, but my personal interest in topics like today's, beyond all the defense gigs that I have on the side, and believe it or not, what the ground guided missiles have in common with, the future of mining and everything else. Well, it's a lot, but on the side, I'm looking at investment opportunities as well as current technologies for things like reclamation and reuse of lands that were not previously usable in order to mine scarce minerals and materials for batteries and other things. So this is a pet rock, admittedly, and thank you for inviting me.
Thank you for showing up. Andrew, we go back a few slides and just highlight that real quick before we wrap up? Because we're hitting 2:00 now. Just wrap up what you were looking for.
Oh, yeah. So we have the system that basically is a closed loop system, zero liquid discharge that captures the toxins in the process of cleaning the tailings and capturing the precious metals involved. And that's been our primary target. Like I said, is getting the precious metals out, because with gold prices where they're at today, a mine tailings pile or dump ore pile with 3 to 4 grams of gold per ton, is actually a pretty good, revenue stream. And so, it's activating a lot of opportunities for us. And there are landowners throughout Colorado. Gil mentioned that we're already in relationship with the top 4 property owners in central Colorado who all want their properties cleaned up. And, the government agencies, DRMS, and county agencies, EPA, all want to see a solution, because the property owners are screaming at them like, you have to give us a break. You have to figure out a solution. And nobody's been able to step up to the plate for decades. And so we created, first, just from a timeline standpoint, our partner and founder of the company, was able to prove out this technology to the point of being able to get a permit for a toll mill right on Clear Creek, right off of I-70 in central Colorado. A pilot plant was built and run at about 3 tons an hour for proof of concept. And now we're tearing that down and, going to build that out to a 30 ton per hour commercial scale toll mill or mill that we can use on our own material. And so we're seeking funding, for that application. We also were able to obtain last May the first permit of its kind to as a reclamation permit on a property that we bought. So it's our own property in central Colorado that has a 30 to 40,000 ton pile on it. That we're in the process of cleaning up, in the process of dialing in our mobile system and making that application. And so, we're stopped right now because of weather and waiting for it to warm up so we can get back to work up on site. And also, like I said, trying to get this Gladstone mill, funded so that we can get it rebuilt at the commercial level and just, use this as a showcase for the technology, use both of these sites as a showcase as we expand. And then we'll dial in, production on our mobile system and, look to start deploying. So yeah, go all the way to the end there, Gil, to the.
Yeah, just go to the asks.
Bury an opportunity to look at the MRU.
Oh yeah, so this is the filtration. Yeah, this is our filtration trailer as part of the MRU mobile system. And this configuration changes per application with the size and so on and so forth. And so this was, a series of 55-gallon drums that were filtered initially. So yeah, go on to the ask there, Gil. Yeah, so we are seeking capital to finish building out the Gladstone, take it to that commercial level. And we would be interested in, supporting other stakeholders who have problems. And there have been several of you that have brought issues up in this call. So everybody from landowners to investors, miners, buyers of precious metal, environmental groups. So there's a large community that we can serve with this solution, and we really appreciate the opportunity of being here today, Eugene, and for everybody's contribution to the conversation. If anybody has interest, go ahead and next slide there, Gil. You've got our contact information, and we'd be happy to carry on the conversation.
One more thing I'd like to add. In where I live in Rhode Island, in Newport, Rhode Island, and the Navy was one of the worst polluters of all for decades. And there are dozens of acres of land here that are hazardous waste lands. Is the Navy or have the government have any money for their own properties cleanup?
That I think is a Department of Interior question.
Because we have really nice properties that can't be used right now.
Well, this is Dan.
Go ahead, Dan.
Sorry, this is Dan at Flight Material Sciences, and I've been listening to the presentation. And we keep coming back to what the Department of Defense, Department of War might do. You may not be aware that there's a centralized department for SBIR funding of environmental solutions that stands on its own, and they do things for different branches of the DoD. It's called SERDP. Is anybody familiar with this? I don't mind. I'll put the link into the chat so you can all see it and go to the website. They have their own funding, their own programs, and their last solicitation was released in November. So new projects are being funded now.
Excellent. Thank you so much.
Yeah, that's great. Thank you, Dan. That's what we're here to do is help each other out. Okay, any more questions?
Yeah, just a question for Dan. Dan, do you engage with anyone directly there, or is that, we just follow the format of the website and reach out that way?
Yeah, for most SBIR funding, for these kind of things, you go directly through the front door. They're looking for innovative companies, and they're mandated with getting early stage opportunities into production for themselves that are dual use, which of course this would be. There are other programs for the Department of Defense where it would be helpful to have a lobbyist, and I guess I'll reach out after the meeting and share what I know, having been through this for the past 6 years.
Yeah, and I'll reach out too, because this is to me, this is a solution that people need to be made aware of, and the community needs to be made aware that this solution exists. So I will reach out to them and find out if they would be willing to present on a forum and talk about exactly what they do and how people can engage them.
Great. Well, thank you everybody for your time. We really appreciate it.
Yes, thank you. And so if anybody hadn't been here before, I will go through the transcripts of this, and I will be sending out emails. Each conversation, each point will have a separate email, and then we will look to engage and vet the potential relationships and any other information that people can provide as far as connections and networking. So thank you all again. Appreciate it. I think it went really well. Just because you came in late, Barry, if you'd like to stay and have a conversation, we can let everybody else go, and I'll leave it open for you.
Sure. Thank you very much. Appreciate the time today. Sorry.
Thank you, everyone.
So thank you, everybody. Have a good day.
It was an A+ presentation.
Thanks.
Thank you.
Yeah,
Appreciate
no,
it,
it did good.
Yeah.
So did you have any other questions or anything else you wanted to ask, Barry?
Yeah, I guess the applicability of the technology for coastal areas, I think it was alluded to early on, or in a late question, about properties in Rhode Island. I grew up around Huntsville. I'm pretty sure that I have at least 90% of my body is covered in hazardous materials in some way, shape, form, or fashion. But at the end of the day, I'm looking for applicability for hazardous sites, even oil spills, things like that. Is this? I assume it's scalable. I assume it's mobile. I assume that it can be centrally located. I can package it, build a program around it through NSWC down here, vicinity of Panama City or Tyndall Air Force Base or Eglin or wherever. So can you just give me a 5-second pitch on opportunities like I've described?
Yeah, and absolutely. And that was our vision, is, scalable, modular, deployable all over the world. So that's been our goal all along, and we would love to partner with somebody who has that same vision. The caveat is, full disclosure, is that every material is unique. And so the system is very versatile, but dialing it into any particular solution, is not, an automatic and exact science that we know is only going to take 6 weeks or whatever. But having said that, we had explained earlier that our partner and the inventor of this technology was actually brought in, on the Palestine oil spill, or toxic spill. And so his technology was included. We did not as a company get employed, but he was brought in as an expert to advise and help implement a solution, for that. And so he has experience, in evaluating different sites and different issues. And he would have to speak to, any specific or unique, material or property or whatever that you might have in mind. But theoretically, everything you're saying is exactly, our vision.
Right. So in the limited time, I can see numerous applications. I see your capability as also being packaged as a service.
Yes.
Based on what you just said, I mean, you can establish a center of excellence. You can have the capabilities there. You can do flyaways. You can do hazmat, rapid reaction. You can go kick in the doors for the Corps of Engineers, whatever you want to do. But not knowing and I don't need to know what the architecture of your solution is, but those are the types of things that would be helpful in the future. What's your base technology? And I know everything is tailorable, everything is unique. I got all that. So those are the questions that I would get as I package things up. My DNA is business development programs. Currently a retired Army strategist, worked with Corps of Engineers, foreign area officer, East Europe and Russia. And one of the projects that I put together that it took the Corps of Engineers 10 years after I left and went on to another assignment was cleanup of ranges, believe it or not, in Ukraine after the former Soviet Union, supposedly fell, right?
Yeah.
And so we did package financing. We took the requirements as vetted by the host nation, passed through and vetted by and bona fide by the embassy and the country team, brought in UCOM, all the J4 Bubbas and everybody else, and everybody gets a vote, right? And then you bring it across and you push it through the headquarters, Army Corps of Engineers, not the North Atlantic Division, which I was in, get their vote, and then have them wrap a project around it. So the bona fides of the United States government was there. And then we went out for long-term bond financing on Wall Street in one of the first public-private partnerships that I was ever involved in. So when they say it took a village, that one was a huge undertaking. In this case, you've got a product that is fully capable of meeting those needs, as opposed to what we were doing is kind of starting from a ground zero, from a concept side, and how to build national level recovery capability after all that stuff. But I think that you're going to want to make this international if you know what's going on around the world today. It's one big hazmat zone, right?
Yeah.
You probably know more about Bureau of Land Management than I do. My son-in-law just happened to work there for way too many years before he escaped to the Army Corps of Engineers and took a step back. But yeah, this is all very interesting. I'd love to stay in touch and talk more if possible.
Yeah, absolutely. We would definitely be interested. I mean, it's, as you've already articulated, the capacity or the potential of this technology is enormous and, beyond what my partners and I are going to be able to achieve in our lifetimes. And so, we would love to partner with people, who can basically take some of it, some piece of it, or some particular application of it, or, some part of the puzzle and, help build it out and even make it a separate, entity and where there's, partnerships and things involved. And so, we're looking for that kind of person or opportunity, as well as, what we're focused on in Colorado.
Absolutely. I don't have anything else for this time period, and I'd love to get my thoughts together, visit a couple of websites, and then get in touch with you again.
Absolutely.
And Eugene, thanks very much. I got Eugene, I got your invitation, and then Jason Papapatis invited me as well.
Hey, this is Brian Crowley. I'd like to add a little value to this conversation with just a theoretical project idea. So I zoomed in on Rhode Island, and it looks like there's a Quonset state airport that the National Guard uses. Okay, so I could imagine a pre-staged, pre-washed, pre-sanitized, locally sourced pile of gravel that could be used for concrete and emergency use at the airport, which is transferable up into the Arctic, where you could send a device up there to wash mine tailings piles to then suddenly be able to build an airport or improve an airport or port infrastructure very rapidly without actually having to mine the aggregate first.
Yeah.
And then you're virtually eliminating all of the environmental hazards from the process of doing so, which also allows you to stockpile it at strategic locations without risk.
Yeah.
I wanted to talk to Tank. Are you there? You came in late.
Yeah, I'm here. Barry Blackman's here.
Yeah, but I got Tank O'Brien came in.
Muted.
All right, you're muted, Tank, if you're talking. I just wanted to find out if there was anything specific you wanted to ask before we wrapped up, or if you just were here to get a copy of the recording. All right, I'm not hearing from Tank. So. All right, so I don't know if you wanted to put an email in the chat, Barry. Oh, there's Tank.
Yeah, I'm sorry. Hey, I was having a little computer problem here like this. Nothing to add at this point. Thanks, so.
Okay, just wanted to make sure. So yeah, Barry, if you could put in an email in the chat for Gilbert and Andrew, I'd appreciate it. And then any other questions from anybody? Any other comments? All right, so I'll leave this up just for a little bit, so Barry can get his email in there and copy Andrew and Gilbert's email. And thank you all for being here, Barry. Thanks for staying on beyond the regular time, and look forward to seeing how this moves forward.
Great, thank you, Gene.
Did you have anything for me, Andrew, Gilbert, before we wrapped up?
No, just excellent opportunity and conversation. Appreciate it very much.
Not a problem. Yeah, feedback is always good.
Yeah, appreciate the time today, Eugene, and we can be in conversation about the e-waste when you think it makes sense, or when you manage to schedule the other outfit.
Yeah. When we do it, yeah, that's definitely. I think that's going to be of interest. And sorry about the attendance. I had a lot of people from LinkedIn that accepted my invite, but LinkedIn keeps changing their rules and they keep screwing with me and how I invite people. I don't want to put it out to the entire world, these invitations, because I don't want to get a bunch of people just coming in here and marketing their wares in the chat and stuff like that. And every time I find a workaround to LinkedIn forcing me to invite the entire LinkedIn community to my meetings, they find another way to screw me.
Yeah.
You got a good force multiplier here.
Yeah.
It's a good crowd.
Eugene, can't you send the invite out to friends only?
Nope. No, it goes out to everybody. And so what I was doing is they forced me to put the meeting link in. And so what I was doing for the meeting link was putting in either my LinkedIn profile or the link to the YouTube page for where all the videos are posted. And when I went in there today to change it to the meeting link, it told me that if I change the meeting link, it has to go through an approval process before they will allow it to go out to all the people that accepted it. Which, that's new since the last time we did this. So I don't think everybody there that accepted it on LinkedIn was able to join. So I have to work that out. So I apologize for that, gentlemen, and all those people that did accept it on LinkedIn will get a copy of this sent directly to them, because I do know that there were people from the Defense Threat Reduction Agency that are interested in this. I know DLA, Defense Logistics Agency, was interested in this, and they weren't there.
Can I ask a question? If you had 3 wishes, what are the wishes that you wish that you had to get this technology to go faster? Is it only money that you need, or like, I'm just curious. I like to ask people that.
Yes, you do.
That's a good question.
Yeah, I mean, money's the chief object, but there are levels of expertise within designing and building, the units themselves that, if we had, I mean, we have some decently skilled people and some more on reserve, but, people who are expert in, fluid management. So, we need a few more experts on the team to kind of help lift, do the heavy lifting on the technology as we adjust it from one volume to another and situation to another. So those are really the 2 things.
Yeah, there you go, Dan. That might be good for you, because you can do, your laser etching to make their cleanup of their systems much simpler, I would think.
I'm not so worried about that. And I've been involved in businesses like this since the late 1990s. And it was never a question of the technology, except, the better you get at unit economics, the more appealing it is, of course. It was much more about the business model. And all the guys I knew who were in tailing remediation, they only got their funding after they shifted over to something where the business attracted more capital, like, oh no, we can't depend on China for lithium anymore. Instead of saying I'm a cleanup company, I will get all the lithium out of the tailing pond because we need it as a critical mineral, and then they got their funding. Or yes, of course, it's a nasty tailing pond and it's a chemical hazard, but only when you said, oh, we can do PFAS remediation from fresh water sources did they get their funding. And in this case, because it's comprehensive, I would steer the business model towards the guys with land trusts, and whoever mentioned the Superfund sites was a good lead into that, where you can buy land for 1/10 of a cent per square foot that's contaminated, as long as you take responsibility for cleaning it up. And when you've gone through and cleaned it up, it's now worth $10 a square foot. And there are guys who fund those kind of things, waiting for the solutions that come along that actually do the whole job. And it doesn't matter whether you can go 3 tons an hour or 30 tons an hour, because they were looking at things that took 20 years to clean up, like electro-osmotic radiation. It was all just a matter of unit economics. So to me, it's about reaching out to those guys first and being pulled, instead of trying to push your way into companies who feel they have a cleanup job to do, because those things very rarely get funded properly.
Very good point. Very good point.
Yeah.
So I'll be in touch, and I want to get a better handle on the technology and what makes it special, because like Phoenix Tailings, who got $76 million worth of funding, they were with me at the Techstars Air Force program, and they banged on the door of every Department of Defense organization and subunit along with me, and they never got their funding from there. They always got their money from people on the mining side. So I have lessons learned from them that I can share.
Excellent.
Dan, could you give us just a quick snapshot of the type of spaces that you work in, or different applications even?
Well, I guess I'm a serial entrepreneur, and I've been in clean tech for the past 9 years. I'm currently a startup company called Flight Material Sciences, and we've got a basket of technologies like laser surface functionalization and amorphous metals. If I was pitching flight to you guys, it would either be about functionalizing the surfaces of your materials so there's no residue left behind on the pipes and in the vats after you've gone through the process, or for laser-based cleaning of the surfaces afterwards to make sure that there's no toxic product left anywhere on the inside of your membranes or your tubes or the metal vats or storage units. So those are some of our primary products at Flight. But again, I've been in industrial odor remediation. I was involved with a mining tailing ponds remediation company years ago who claimed at the time they'd pull enough gold and other valuable stuff out of the tailing pond to run the operation at a profit, which of course, that never actually happens in the real world. But it doesn't mean that people don't look at it seriously and wonder how this can fit into their portfolio.
Yeah, thank you for that. Appreciate the breakdown.
Yeah, and Dan, he had the last presentation he presented a month ago on here. So you can always go back and check that video in the repository. Can't remember if I got yours up on. Yeah, I did. I got yours up on the YouTube channel, Dan.
Okay. Yeah, if that technology is helpful for your scale up, I'm glad to collaborate. But I suspect that it's much more fundamental stuff about fluid and solid material handling and separation and scaling up your in-process details, and not so much about things I might be able to improve on the material side. But you let me know. Like when I saw the illustration in your presentation, one of my first thoughts as a materials guy was, my God, the tailing ponds that are coming through, the material is so absolutely corrosive that your nice polymer and metal surfaces are going to be eaten alive as you handle this stuff. But there's solutions out there for that, like amorphous metals and ceramics. But I'm sure you've gotten into some of those details in the past.
Yeah, for sure.
All right.
So, yeah, happy to help. Thank you. Thank you very much, everybody.
Thank you, Dan.
Yeah, thank you, Dan.
Thank you, everybody. I will be sending out invitations for the next one. Right now, I'm looking at every 2 weeks to run these. So the next one are going to be up in the air. We still have the running AI partnered forum that we're doing, the AI symposium. So that was in the email as well. So everybody have a good day.